Okay, so with the question here on tides, all right, it does say that at noon, okay, 12 o'clock, the water level is midway between high water and low water. So there's low water, there's high water, so we're midway, we're about there, okay. So I've sketched this here on my piece of paper here, and essentially that's where we are at noon, right? And that's where we're going to have the center of our oscillation, okay, with SHM. Because if you think about it, the tide then will go to high tide, and then it will drop past the center of oscillation down to low tide, and it'll start to rise again, okay, oscillating then between low and high, and that's our center of oscillation. Now, one thing we need to know, right, a bit of common sense sort of thing, is the time period for tides, okay? And remember that the period of oscillation is for it to complete a full cycle, all right? Now, for it to get from low water to high water, low tide to high tide, it takes 6 hours in total, okay? So that means then the time period, if you think about it, is going to be 12 hours, okay? So 6 hours to get from low to high, and then another 6 hours then to get from high to low, okay? And that cycle gets repeated then twice, obviously, in a day. But the period going from low to high and high to low is 12 hours in total. All right. Now at 12 noon, of course, it's here. All right, and we're assuming then it's going to keep rising to high tide. So if you think about it, then it will. If it's at the center of oscillation at 12 noon, it'll get to high tide by 3 p.m., won't it? It'll take 3 hours to get there, because if you think about it, it's taking 6 hours, isn't it, to get from low all the way up to high. So at 12 noon, we're sort of halfway between low and high, so it's going to take another 3 hours. The other thing I've deduced from the picture as well, from the diagram, is that it's 11 meters to high tide, right? So the depth of the water is 11 meters. The depth of the water then to low tide is just 3 meters. There's not much water there. But what I could work out then was I could work out what the amplitude is, okay? Because if you think about it, low tide is 3 meters, high tide is 11 meters, so therefore there's a gap there of 8 meters, yeah? So that means then the amplitude is going to be 4 meters. So that's the center of our oscillation. It's going to rise up 4, isn't it? And it's going to fall down again, and then to the center, and then another 4 down to low tide. So we know straight away the amplitude is equal to 4. Okay, meters. All right, and from this information, of course, we can work out things like the time period. Well, we've got the time period there. We can work out what omega is. Okay, so if we figure that out, t is 2 pi over omega. So we put 12 in there. Okay, and we can get omega out to be 2 pi over 12, which is of course pi over 6. Okay, so that's my omega. That's good. So I know omega, I know A, and then it enables me then to answer part A, where it says find an expression for x in terms of t. So remember, for the displacement x, we either use A sine omega t or A cos omega t. Now, because they pitch this to us at 12 noon, and they say, look, it's at the center, don't they? It's between low and high at 12 noon. It's at the center, isn't it, in terms of where we're at the beginning of our time at 12 noon. So because it's at the center, we can use the sine one. All right. So we've got that there. But for a full expression, right, and this is worth 4 marks, they'd expect you to put in A and omega, and we've obviously worked that out. A is 4, okay, and omega is pi over 6. Okay. So that is our expression for x in terms of t. Part B then, it says find the depth of the water in the harbour at 7 p.m. Okay, so at 7 p.m, what's the depth of the water? So all you've got to do is, okay, you just need to say, look, when time is 7, when t is 7 p.m, of course, we're going to just substitute here t to be 7, yeah, because this is 7 hours after noon, okay, quite simply, isn't it? So we're going to set t to equal 7, so we'll put that in there. So x will equal 4 sine pi over 6 times 7. Okay, so I'll get my calculator. 4 sine pi over 6 times 7, and I get out minus 2. So x is going to be minus 2. Now that's okay, right? We can have negative. What that is saying, of course, if we go back to our initial diagram, all right, is that we're going to be down here, yeah, because I've got x here going up. That's the direction of increasing x. So when t is 7, x is minus 2. So we're going to be here somewhere. Well, in fact, we're going to be here, aren't we? If x is minus 2. That's where we're going to be here. So we're going to be half of this. So in terms of the depth, if I'm there, well, this is going to be 2 meters, isn't it? Plus 3 meters. That's going to be 5 meters. So the water level is there. Think about it, right? Because x is minus 2. So that means I'm going to have 2 meters there, and 3 meters is 5 meters. So I can say the depth of the water will equal to 5 meters in total when x is equal to minus 2.